all the name reactions that we teach in Organic 1 and Organic 2 are named after all white men. So I find that very discouraging to women in the field or people of color in the field, because it looks like nobody's ever going to name a reaction around your name.
That was Maria Gallardo-Williams, an organic chemistry teaching professor from North Carolina State University. She's describing a cultural practice in chemistry that has increasingly come under scrutiny, naming certain chemical reactions after the scientists who discovered them, or someone who advanced the technique in a significant way. We call these name reactions. For example, the Grignard reaction, the Swern oxidation, or the Diels-Alder reaction. These names are widely used, but chemists have raised concerns that the highly visible roster of reaction names doesn't reflect the current demographics of the chemistry community. And these scientists question whether the culture of name reactions is serving chemists well.
I mean, it's subtle, right? It shouldn't be a big deal. It shouldn't be a big deal, but it is a big deal.
It turns out chemists have a lot of different perspectives on this particular issue, which we're going to delve into in this episode of Stereochemistry. I'm your host, Kerri Jansen, and I've asked C&EN reporter Leigh Krietsch Boerner to join us since she's the organic chemistry expert around here. Hi, Leigh.
Hello.
So I know that you've been talking to a lot of chemists about this subject over the last few weeks. What have you learned?
Well, what really brought this to my attention was actually a Twitter thread started by Maria, whom we heard at the beginning of the episode. In early June, she posted about how she's trying to include more references to Black chemists in her teaching to balance out the mentions of reactions named after white men. Mark Levin, an organic professor at the University of Chicago, jumped in to say that maybe organic chemists should remove names of scientists from undergraduate organic classes altogether. The thread then quickly turned to whether using name reactions is elitist or exclusionary, what the purpose of them is, and if the practice should continue. If I'm remembering correctly, the phrase death to named reactions was used.
We'll definitely link to that thread if you want to read more. But it sounds like there are some strong opinions about this.
Yeah, I talked to almost 20 people, including several organic chemists that we'll hear from in this episode, and their perspectives were all over the board. And it's actually kind of a sensitive subject. Not everyone is super into talking about this. But I was able to get a sense of what some of the key concerns are around name reactions and what people think their future should be.
Let's start with some background. How did this practice get started of naming reactions after people?
Well, a reaction is usually named after the person who discovered it or developed it. So one reason chemists started this practice was to honor a contribution to chemistry. This goes back to the mid-1800s, although it's pretty hard to pin down what the first name reaction was. Today, there are hundreds of these things. The Merck Index, a huge authoritative collection of chemicals, drugs, and biologicals, lists about 470 name reactions. But then I found out about a 3,800-page tome called the Comprehensive Organic Name Reactions and Reagents. The author, Zhirong Daniel Wang, told me that there are about 675 name reactions, although he's getting ready to put out a new edition, and he's going to add even more.
So organic chemists learned 675 reactions?
No, that's a bit nuts. But some organic chemists have probably around 300 or so memorized.
That's still a lot of things to memorize.
It is. But when practicing organic chemistry, it's useful to have a shorter way to help simplify what might be a complicated chemical transformation. So instead of talking about it like a 3,3 sigmatropic rearrangement of an allyl-vinyl ether, you can just say Claisen rearrangement.
Right, that's definitely easier.
Exactly. And that's another big part of why the use of name reactions is so widespread. I spoke with Vi Dong, an organic professor at the University of California, Irvine, to learn more about how name reactions are used.
It's a sort of language when you say, performed an asymmetric sharpless epoxidation. There, in just 3 words, you pretty much have conveyed a ton of information to the other person you're speaking to.
Vi says she does use name reactions in her classroom and lab, but she's not super formal about them.
I think for me, I don't expect students to just sit down and memorize the named reactions, but I say that it's a really handy way to make an extra connection in your brain to something that's maybe more personal, more human. I do remember meeting Kolenkovich and trying to learn to pronounce his name exactly, learning about his named reaction, introducing him at a talk. And now, I'll never forget the Kolenkovich reaction.
Which is making cyclopropanol derivatives with a Grignard reagent and an ester over a titanium-4 isopropoxide catalyst.
Of course. Now, Some other people I spoke with noted that being able to connect a name reaction with a face is maybe less useful for beginners in organic chemistry who may not have ever heard of these people before. For students, knowing name reactions may be more about showing that they should be taken seriously as chemistry students.
It was in my head all of my academic career. And of course, I perpetuated that with my own students by telling them, you need to know the names of these reactions, because that is how you're going to show people that you're competent and that you understand organic chemistry.
That's Amanda Bryant-Friedrich, professor of pharmaceutical sciences and the dean of the graduate school at Wayne State University. Referring to name reactions is part of thinking of yourself as an organic chemist, she says.
You know, the interesting thing is that it's part of the culture. When you're an organic chemist, you almost wear it as a badge of honor if you can say every reaction by name that's out there.
So knowing a bunch of name reactions is kind of proof that you know your stuff. You're on the inside.
Yeah, and a lot of people I talked to said this, that students, especially graduate students, should and are expected to know some name reactions. And even though most say that memorizing these names has nothing to do with a student's ability to understand the chemistry, there are some that use it as a sort of test. And if these students, quote unquote, fail this test, they might be looked down upon in a way. So someone who doesn't know all the right name reactions for whatever reason may feel like they can't participate fully in organic chemistry. Here's Maria again.
So there is a degree of snobbery. There's a degree of being selective. If you can't keep up with all these name reactions, then maybe you shouldn't be an organic chemist, which I hate. I hate things that are exclusionary by design, right? I mean, to me, that's the opposite of what we should be doing.
And looking at that roster of name reactions gets at a bigger issue, which is who those names represent, or don't. Here's Amanda again.
One of the questions that we're walking around, and one of the things that we're not talking about, is that most of these are white men. And so that the fact that they are white men means that the idea of name reactions and the reactions in organic chemistry they've almost all been given to one sector of the world population, white men. And I would imagine that if you even talked to a young woman and told her about the Goldberg reaction, she would definitely first think that that's a man and it's a white man.
It's actually not. That one's named after Irma Goldberg, one of the few reactions named after a woman.
There's a problem with that, definitely. As we move forward now in science and we look at these names, we have to be more aware of the fact of what it is that we're doing. We're being very exclusive there. It's an exclusive group of individuals. And I don't know if that will serve us well in the future.
Okay, to hear that the bulk of reactions from the 19th to the mid-20th centuries were named after white men does not exactly surprise me, but I'm curious, what's the breakdown like today for these hundreds of name reactions?
Well, it's hard to know the exact numbers because sometimes there's not that much information about the history of a reaction, and sometimes that would involve us making a call about race, ethnicity, or gender that may not be correct. To get a better handle on this, I called up Kevin Shea, an organic chemistry professor at Smith College. In 2010, Shea and one of his undergraduate students, Julie Olson, wrote a paper in the journal Accounts of Chemical Research called Named Reactions Discovered and Developed by Women.
When we started looking into reactions named for women, it was really kind of depressing.
Basically, because there were so few, and sometimes who the reaction is named after is not straightforward.
A couple of them, it's ambiguous, right? Because it's like husband and wife, same last name, right?
Almost all of the women that worked in chemistry back in the early to mid part of the last century were married to chemists. Irma Goldberg was married to chemist Fritz Ullmann, but she didn't change her name.
So that's how many?
Let's see. There's the Pilati-Robinson-Perol synthesis, the Robinson part after Gertrude and Robert Robinson, the Hunsticker reaction after Clara and Heinz Hunsticker, the Goldberg reaction, the Jordan-Ullmann-Goldberg reaction, the Catalani reaction, discovered by Marta Catalani in the 70s, and most recent, the Staudinger-Bertozzi ligation, partly after Carolyn Bertozzi. That's 6 total. But since we can't be sure that the Robinson and Hunsticker reactions were named after the female half of those couples, that makes 4 for sure.
4 out of 600 something.
Yeah, There are also a handful named after Asian men, for example, Sonogashiri coupling, the Suzuki reaction, and a few more. It's even harder to find reactions named after Black, Latinx, or Indigenous people. The name reactions list is definitely heavy with chemists who are male and white, typically American or European. As Kevin and others I spoke with pointed out, that's partly the result of the field's long legacy of denying access to people who did not fit that profile. Here's Amanda again.
Oh, yeah, that's what it's all about, right? It's about access. And so you can think about the amount of time that people, let's say African Americans, have actually been involved in academic science and the ways that we've actually become a part of those communities. Yeah, I'm sure we've missed a lot. We've seen stories out there like people who developed surgical methods that were attributed to people of color, but they did not get the actual recognition for that because they didn't have the right title. So access has been and always probably will be in my lifetime one of the biggest issues that colors everything that we're talking about right now.
Who was allowed to be in the room, both in the past and now, of course, has a giant influence on the people we see represented in name reactions. And as several chemists I spoke with noted, not only does a lack of reactions named for women and people of color highlight a broader systemic issue within chemistry, but it also has the potential to be discouraging to chemists who don't see people who look like them on these lists.
When I was learning about the name reactions and becoming a chemist myself, I recognized pretty early on that there was no one that looked like me or sounded like me or anything that was actually represented by those names. Did it mean that I felt like I could never have my own name reaction? No. It is, of course, a problem. It's just like walking into buildings where there are these portraits of all white men everywhere. This is just not a visual, it's written. It's ingrained in our discipline. So yeah, it's definitely exclusive. And I think for future generations, it's going to be even more of that.
But she says that she hopes that chemists will recognize this and change it. But that brings up the process of naming reactions itself.
Right, how does that work? Who decides which reactions get named and what they're called? And which scientists are important enough to have the reaction named after them?
Well, unlike how we name elements or chemicals, there's no central organization that decides how chemists name reactions. I spoke with Eric Jacobson, an organic chemistry professor at Harvard University who has a reaction named after him, the Jacobson epoxidation. He says that the process is pretty subjective.
It seems it's kind of an arbitrary thing. And first of all, it's almost never the person who discovers the reaction who names it after themselves. There are a few very, very sort of peculiar exceptions to that. But for the most part, vast majority of cases, other people name it. And I think it's probably most often people who use the reaction in a synthesis will then refer to that reaction by the person's name.
Many chemists say that the system, or lack thereof, can be problematic. It's such a word-of-mouth phenomenon.
An organic process, you might say?
Sure. But the point is that what each reaction gets called depends on who you are. For example, is it the Buchwald-Hartwig amination, or is it the Hartwig-Buchwald? If we think of it as a language, everybody has their own dialect based on what they've learned from the people around them. As Carmen Drahl wrote in C&EN in 2010, many people refer to the Mizuroki-Heck reaction as just the Heck reaction, even though Tsutomu Mizuroki developed a lot of the chemistry behind it.
It gets messy if different people discovered the reaction and made it practical, let's say, or if competing groups were working on the same reaction at the same time, and then how do you parse credit that way? So it's often an unpleasantness to it, even though it's probably intended to be a nice thing, a thing of recognition. It can be divisive and actually hurtful to people if they're not recognized, even though they made important contributions to it.
As a postdoc, Eric worked on a reaction later named after his advisor, Barry Sharpless. That's the Sharpless dihydroxylation reaction. Then in 1990, shortly after Eric started his own lab, a C&EN reporter covering a method for the catalytic asymmetric epoxidation of unsubstituted olefins dubbed it the Jacobson epoxidation. The name stuck, although Eric remembers having mixed feelings about it at the time.
At the time, I was kind of, frankly, terrified because at that point, the reaction wasn't very useful yet, and I wasn't sure if it ever would be. And it just seemed like a lot more attention than it should be getting. I mean, obviously on some level, I was happy that it was getting attention, and the students in my group were excited about it. But I frankly, I was embarrassed, and I thought it was a little bizarre.
He's been name dropped more recently too, but C&EN had nothing to do with it this time.
A paper came out a couple of years ago where in the title it said that it used the Jacobson amine. And I frankly didn't know what that was. I really didn't know that I had an amine, and I had to read the paper to find out what it was.
Eric says trying to get things named after him isn't his goal as a chemist, but it was flattering. His personal experiences aside, he says chemists need to think carefully about whether using name reactions does make women and people of color feel excluded.
I think it's important to ask people in that situation if that's the case. I hope that we all have as a goal to increase representation in our field and to attract the very best people, very best scientists for our field, regardless of their race and gender. So if something like that dissuades people, it discourages people, we definitely should think about it carefully.
So how organic chemists use the language of name reactions can potentially have an impact on people that don't look like the white men that reactions are mainly named after. And chemists are trying to figure out how to deal with these issues.
We're going to take a short break, and then we'll hear from these chemists and others about what they see in the future for organic chemistry's culture of name reactions. Hi, I'm Gina Vitale, an assistant editor at C&EN. If you're interested in the future of chemistry across all disciplines, check out this year's class of Talented 12 Early Career Chemists. Every year, C&EN highlights a dozen rising stars in chemistry who are using their creativity and chemical know-how to solve some of science's toughest problems. The class of 2020 includes researchers who are hunting for compounds in interstellar space, figuring out better ways to diagnose tuberculosis, and dreaming up blueprints for building the next generation of computer chips. Read all about the 2020 Talented 12 at cenm.ag/T12. We'll include that link in this episode's description. You can also listen to the Dazzling Dozen share their research at the C&EN Futures Festival, a virtual event coming up on August 25th to 26th. As well as catching the Talented 12 speak, you can also tune in to hear leaders from across the chemistry enterprise discuss the people, ideas, and discoveries that will shape the future of science. C&EN's Futures Festival is a free event, and you can register at futuresfestival.org. It'll be recorded too, so you can catch up with the action on demand at futuresfestival.org. Now back to the show. So Leigh, coming back to our discussion about name reactions in organic chemistry, we've now heard reasons in favor of using name reactions and reasons against. You've heard from a lot of people on this subject, even though we couldn't include all of them in this episode. Where do these people think we should go from here? Will organic chemists continue to use name reactions?
Well, some chemists would like to see more of an emphasis on descriptive names for reactions instead, like the aldol condensation or olefin metathesis, which is sometimes called the Grubbs reaction. But others, such as Jin-Kwan Yu, an organic chemistry professor at Scripps Research, see the culture of name reactions as motivational and want to keep the tradition going.
For myself, I'm a person of color, and when I see name reactions, my first feeling is, I'm inspired because I admire whoever the scientists who discovered the reaction, and I'm grateful to them for their discovery, and I'm enjoying, benefiting from those discoveries. And I can only be inspired to dream maybe one day my name, will be attached to a reaction. If I'm a student, I hope that's how they would be inspired,
Jin says he's confident that, while the roster of name reactions is pretty white and male at the moment, that will change. And it's already changing as new generations of chemists have a shot at discovering reactions. And some, like V from UC Irvine, do not see the use of name reactions as detrimental to the field.
I could imagine if we put so much emphasis on the importance of having a named reaction or memorizing all of these 450 reactions and knowing who all the people that invented them were, I could see how that could be a problem. I just don't think that that's sort of something that drives the field right now.
There's also the question of what to do with all the existing name reactions if the practice were ended. Would chemists just stop using them?
Right. That is a hard question to answer. Eric from Harvard noted that, at the very least, new chemists will need to know name reactions in order to understand references to them in the literature.
If we were to start from scratch right now, I might make the argument that there's no value to it at all. And especially if those names, alienate people in any way or discourage people in any way because it's a restricted list. But we're not starting today, right? So there is this history to the field and there's a literature to the field. And, for people, graduate students need to learn how to read the literature, and they also need to learn how to do new chemistry based on existing chemistry. I think that it is important for them to know name reactions, or at the very least to know where to look them up and where to find them.
Amanda from Wayne State also notes that we have to work with what we have.
We know in that world that we're always talking about the exact same reaction by giving it that name. Now, could we have done that by giving it a name that's related to the actual functional groups involved or the mechanism involved? Sure, but that was not what we actually inherited. So I think it works very well for people now to use those names. I would love to see just having more inclusion of others. And I would imagine, and I have never done the research myself, but I would imagine that there are women, there are people of color who have done important things that we could add to that library so that people would know that there were diverse people out there who contributed to the advancement of organic chemistry and are name-worthy. Making that list more inclusive would probably be a better way of attacking it than getting rid of it altogether.
In fact, most of the people I spoke with do not want to end the use of name reactions. But there is a growing movement to include more context around those reactions when teaching them, and to recognize that there have been reactions named for men who exploited the work of women, people of color, and even their own white male colleagues.
I wish that there was a way where we could make that known when people learn the reactions. Or I know it's just too difficult to take the name away, especially if it's been around for hundreds of years or whatever. But it really can trigger in your mind when you know the history behind that person. If that person was someone who, honest to goodness, took away opportunities from people and took away the access that we just talked about, and then we constantly commemorate their contributions, that's hard. That is hard.
Of course, trying to build a more representative environment for organic chemistry doesn't end at discussing the history of name reactions in chemistry classes. What many people that I talked to agreed on is that the organic chemistry community needs to do a better job at inclusion and work harder to highlight more women and people of color in the classroom and lab. Brandon Quillian, an associate professor of organic chemistry at Georgia Southern University, agrees.
I think, especially from the perspective of where you can find women and minorities, I think that would definitely be very inspiring. I think it would be more of an attention getter for those select people, because it would have helped me out without a doubt.
Kevin from Smith College says that professors can help students see past the white wall of history by talking about how the field is changing and pointing out modern women and people of color who are doing important work in organic chemistry.
You have to admit that it is exclusionary. There's no question that it is. And I think if you don't address that in your classes, then you're perpetuating the exclusionary nature of that.
As for Maria from NC State, she's hoping organic chemists will do away with name reactions for good, abandoning them to the trash bin along with other outdated techniques like mouth pipetting.
I mean, I don't see the need to teach my students all these names. They're not going to enhance their understanding of chemistry, right? But then at the same time, if they're going to go to graduate school, I don't want them to look like fools and not know that there are name reactions. So you're like between a rock and a hard place, because you have to make sure that your students look good when they get to grad school. So you have to let them know that this is a thing that other people do. They do it because we've always done it that way. And to look like a cultured and smart organic chemist, you had to do it. You had to drop names and you had to use name reactions because it was the way we spoke. That doesn't mean that we have to speak like that forever.
Well, thank you, Leigh, for helping us examine this issue. So what happens next? Are chemists going to do anything to change this?
Well, not everyone thinks it's a problem, but several people I interviewed said, I've never really thought about this before. Yeah, we should really examine that. V from UC Irvine pointed me toward a Carolyn Bertozzi tweet from a few days ago referring to the Cope rearrangement as the Hardy Cope. Elizabeth Hardy was a student of Arthur Cope's, and the reaction was part of her thesis work. Organic chemists have the ability to change the narrative here, and most people I talked to said that they hope this podcast will launch a bigger conversation around it.
And we'd like to know what you think about this subject. You can find C&EN on Twitter at cenmag. I'm at Absolute Kerri.
And my Twitter handle is at Leigh J.K. Boerner. We'll include those in this episode's description. Use the hashtag #NameReactions so others can find your comments.
And if Twitter's not your thing, you can always email us at cen_multimedia@acs.org.
And I'd like to thank all the people who talked to me about this, both those that we included in the podcast and the following people we couldn't fit in. Carolyn Bertozzi, Scott Denmark, John Hartwig, Cami Hull, Mark Levin, G. Jacques Lee, Jeff Seaman, Stephen Stinson, Zirong Daniel Wang, and the people who spoke to me on background.
This episode of Stereochemistry was written by Leigh Krietsch Boerner and produced by me, Kerri Jansen. It was edited by Michael Torres and Amanda Yarnell. Heather Holt was our copy editor. The music in this episode was Uncle Jojo by Dialco and Duda by Ian Post. Stereochemistry will be back next month with a new episode. Be sure to subscribe so you don't miss it. Stereochemistry is the official podcast of Chemical and Engineering News, which is published by the American Chemical Society.
Thanks for listening.